Alright guys, we're going to do this little problem right here. This is one of the harder AMC problems, alright? And I initially thought that this was the answer right here. But I was wrong, alright? So I got this question wrong. And we're gonna go through my sort of thought process, okay? So I thought, right, so they give us a little triangle that looks like this. So they give us a triangle that looks like this. They have square S right here. Alright, here, let's read the problem first. It says, Farmer Pythagoras has a field in the shape of a right triangle. The right triangle's length have lengths 3 and 4 units. In the corner where those sides meet at a right angle, he leaves a small unplanted square S, so S right here. He leaves small so that from the air it looks like a right angle symbol. The rest of the field is unplanted. The shortest distance from S to the hypotenuse is 2 units, and they give us 3 and then 4 right here. Alright, what fraction of the field is planted, okay? So this is the unplanted right here. Everything else is unplanted. So what I was assuming in this problem is that this 2 right here, this sort of dashed line would go down to the vertex. And if you assume that, then you'd get this answer right here, alright? And so that's the key right there. That's the problem that I ran into. I was assuming things, and in math problems you can never assume anything. Just remember that, alright? And so I found the solution on artofproblemsolving.com, and I want to better articulate the solution to you guys, alright? So here's a video for it. So it's asking us what fraction of the field is unplanted. We know that S is unplanted, so we're going to call the sides of S x, alright? So you have x and x right here, and we know the area of a square is x squared, okay? And so now let's try to separate this triangle into smaller triangles, right? So that's one of our tricks when we're solving geometry problems. The key is to either cut something up into smaller pieces or extend it into longer pieces, all right? That's our strategy right there. So we're going to try cutting it up into pieces, all right? So we're going to get this corner of S right here. We're going to get this vertex, and we're going to extend it out to right here. All right, we're going to do the same with this one right here. Alright, and look at this. We've created smaller triangles, right? We have one right triangle right here. Here's our little right angle. We have another right triangle right here. We have our side length of 3 right here. We have a side length of 4 right here, right? And we know that the hypotenuse of this huge right triangle here is 5. And now it should be a little easier for you to solve for, because our goal here is to solve for S and then take the whole area and subtract it by S and put that over S, alright? That's how we find the planted amount, okay? So let's try to find the area of all of these and then put that in terms of X and then add it up so that it adds up to this huge right triangle right here. And let me show you what I mean by that, alright? So we're going to try to find the area of this triangle right here, alright? So what is it? Well, we have our base, which is going to be X, right? So that's a length of a square, or of this square. Then we have our height, which is 3. So, our height, which is 3 minus x, right? Because we just want this thing right here. And 3 constitutes for this entire thing right here, right? And we don't want this x portion of it, so we just do 3 minus x. And so we do base, which is x, times height, which is 3, minus x. We don't want this x portion of it, so we're going to minus x. Alright, remember it's a triangle, so we divide by 2. Same thing with this one right here, right? We have our base, which is x right here, and we have our height, which is, or we have our base, which is 4 minus x. Alright, we don't want this x portion, times our height, which is x right here, so we do plus x times 4 minus x divided by 2, alright? And then we want to do this plus x squared right here, right? Because we're trying to add up all these small triangles right here, Alright, and show that it is equal to this large triangle right here. Alright, so we're going to x times x is x squared. Then, so we found this, and we found this. What is this one now? Well, we have our base, which is 5 right here, which is the hypotenuse. And then our height, well, our height is just 2, right? Because that's the distance from our base to our vertex right here. So it's 5 times 2, which is 10, divided by 2, which is 5. Alright, and so we know that this triangle right here, that triangle right here, is equal to 5. That's the area. Alright? So 5 right here, plus this, which is this triangle right here, plus this thing right here, which is this triangle right here, plus x squared, which is this small square right here, is equal to 6, right? Because 6 is 3 times 4, which is 12 divided by 2, which is 6, and that is the area of this whole big triangle, alright? So it's equal to 6. Let's add that right there. So now all we want to do is solve for x, alright? So let's solve for x. So we have 5, we have this 5 right here, it's an integer, alright? So we're going to subtract 5 on both sides. That means we have 1 is equal to x times 3 minus x. Alright, we just subtracted 5 on both sides, over 2, plus x times 4 minus x, divided by 2 plus x squared. Alright, now let's try to multiply this out so it makes it a little easier for us, okay? So we have 3x. Alright, we're just distributing, alright? 3x minus x squared divided by 2 plus 4x minus x squared divided by 2 plus x squared is equal to 1, alright? Then we don't like fractions over here, right? So we're gonna multiply both sides by 2. I should multiply this by 2, so we have 2 is equal to 3x minus x squared. Oh, whoops, 3x plus 4x minus x squared plus x squared. X squared right here and x squared right here, they can cancel out. So we have 3x plus 4x, which is 7x. So where should I write that? Alright, we're gonna write it right here. Hold on 1 second. Oh wait, I'm sorry. We forgot to multiply this x squared by 2 right here. Alright, because remember we're multiplying both sides by 2, alright? So we have minus x squared, which is negative 2x squared. So this negative 2x squared can cancel out with this positive 2x squared. And there we go. We have 2 is equal to 3x plus 4x. Alright, 3x plus 4x is 7x. So we're going to move this down here. My mistake. So 2 is equal to 3x plus 4x, which is 7x, alright? Which is 7x. And then x, that means x is equal to 2 over 7. Alright? So there we go. We just found our x value, and that's important, right? Because x is this side value right here, this square. And so that tells us if we do x squared, which is the area of that little square, x squared is 4 over 49. Alright, 4 over 49. And we know that the whole area of this huge triangle right here, alright, the planted plus unplanted, right? Planted plus unplanted is equal to 6. Sometimes we subtract this unplanted side in order to get our planted area. Alright? and we're going to divide that all by the whole triangle, right? So this is our planted area. This is what our planted is, divided by the whole planted plus unplanted. And that will tell us the fraction of what is planted, okay? So if we do this by hand, it's going to be a little hard, but I've already done it on my piece of paper. We get, our answer is, so if we get 6 minus 449, we get 290 over 49. And we can just translate the number 6 into 294 over 49. Alright, this is the same thing as 6. These 49s can cancel out. And if we simplify this down, if we simplify this fraction down, it will equal to D right here, right? That was a quite complicated problem, alright? And so the key to this problem here, the key what I got wrong, is that you can never assume anything about geometry, alright? And the key to solving, these geometry type of problems is either you want to cut the triangle or figure, whatever, into smaller pieces. You either want to do that, cut it into smaller pieces, triangles preferably, because those are very easy to find the area of, or you want to extend the triangle or whatever shape into something longer where you can see the area of that extended shape. Alright, and there you go. That's how you do it. And if you didn't understand, you can go back to the video, or you can head over to the Art of Problem Solving website to see what happened.